Hi, welcome to my presentation video. I'm Shani Ramanish, electronic designer and manager of various projects. I invite you to watch parts of projects which I have done so far. You'll see in this video. First, we're going to watch the creative and innovative project of electrifying CG125 motorcycles. We're also going to see the electrical kitchen hood and a 1.5 kilowatts water-cooled motor. Next, we're going to watch the 50 kilowatts BLDC motor. We're also going to see the thruster repair and design project. Then we're going to watch the innovative gas meter and my university thesis project, that is the syringe pump. Finally, we're going to see the interesting and personal aeroponic bucket. Stay tuned. As I mentioned in SOP and CV, I used to undertake research in Damavand Science and Technology Park. At first, I used to work as an electronics, control and automation designer. Then I was promoted and took responsibility not only as a designer but also a project manager. Damavand Science and Technology Park and clients didn't let me show all of the projects I have done. They allowed me to display the final product and their details in some of the projects. I try to show you a summary of them. I add that I also designed and made several devices outside of the park. But it's going to take time to show them out. CG125 motorcycle projects, which we'll see, were planned commercial products. I'll explain it in detail. I was involved in this project as a project manager and electronic control designer. The rest of the team included 2 electrical machinery designers and a mechanical designer. A mechanical and an electrical consultant aided us in this project. It's necessary that I explain the reasons why the client requested this project at first. A large part of intra-city transportation is carried out by motorcycle in Iran. Courier motorcyclists who do most of Iran's transportation usually use Honda CG125 motorcycles. I add that these vehicles cause air and noise pollution and consume a great deal of gasoline. In Iran, the government supplies gasoline subsidies, so gasoline price is much lower than its global price. One of the problems of the established governments is paying off gasoline subsidies. They always face challenges and problems to increase the cost of gasoline. There are several beneficial effects in this plan. First, it will reduce the cost of energy consumption. It has benefits for both the motorcyclists and the government. The high consumption of these engines is due to wear and tear and outdated design. According to our field calculations, it's about 3 liters per 100 kilometers. Even considering the gasoline subsidy, it's worth electrifying CG125 engines. And it's being cost-effective for the motorcyclists. It will reduce air pollution in metropolises, most of which is due to the use of these engines. The government or any relevant organization would bear the cost of electrifying motorcycles. We offered that they would use the shared batteries. Motorcyclists should replace their empty battery with charged batteries in electrical charging stations, and the batteries would belong to the government. According to our initial research, we concluded that a 3 to 5 kilowatts motor was suitable for this purpose. And the client considered the largest speed equal to 80 kilometers per hour. All BLDC motors were designed at 72 volts and have the ability to pass 80 amps in a small period of time. I should mention that I've designed and implemented all the motor drivers by myself. They had a data logger which connected to the computer through LabVIEW. It also had the ability to record information in a computer and in a flash memory for research purposes. The motors could be controlled both through a throttle handle and a computer. I've equipped every motor driver with a soft start and soft stop. Every data logger has had a current and temperature control. As you can see in the picture, the motor drivers include two separate circuits. One is control and the other is power. They are connected by wires, but they've connected with connectors in newer models. I've run all the drivers without driver IC and with the STM32 ARM microcontroller. Although a bootstrap circuit is easier and cheaper, it doesn't have the ability for higher powers. And I've implemented a general driver which can be used in all high power motors. I've used the isolated power source and totem pole circuit MOSFET gate driver. As you can see in the picture, I've wrapped the general ferrite core transformer for all sources. Even the power supply of the control circuit has been isolated from the motor supply, so it wouldn't be affected by the motor electromagnetic noise. I placed some small transformers around the control circuit for each supply in the later versions, because it reduced the height of the control board. 4 parallel transistors have been used in each leg. The best model that I found in Iran is IRFP4668. It has the ability to withstand 200 volts and 130 amps with 8 milliohms radius. They were stuck on the heatsink due to the decreasing amount of resistance and losses. It has the ability to pass a very high instantaneous current during the start of the motor. I also have used the decoupling capacitors to remove ripples and noises. It's true that there was no need for capacitors because of connecting to a battery. But we didn't have a battery at first and we were doing the initial test with the power supply, so I decided to put these in. In the drivers, I've used the ACS current sensor, which had the ability to measure up to 100 amps. Although we gave a regenerating brakes design in the initial plans, they refused, because they had license problems. Three plans were given, based on which the project was formed and implemented with the client's approval. The first design, which was the simplest design and the most common, was the outrunner motor. It was embedded in the wheel. In this case, a ring with 32 small magnets with different poles was placed in the motor ring as a rotor. And the middle shaft was also connected to the stator. As you can see in this video, the driver connects to the computer and information and even control has been done by it. The second plan was a very complicated and challenging implementation. We replaced the dynamo with the motor. As you can see in the video, the dynamo is connected to the gearbox and moves by the motor. This plan has been given for several reasons. First, it was more difficult to copy by different people. Second, motorcyclists who like to his or her motorcycle outwardly would welcome. because it would change the minimal amounts in the motorcycle appearance and mechanics. Finally, the gearbox still would remain, and motorcyclists would still use the gear shift and clutch. It would give the feeling of the old-fashioned ride. A rotor with 4 permanent magnet poles, which was designed as in Runner.
چند ولته؟
تقریبا 4.5 بود.
Because of the cheaper final design, the SLA lead-acid batteries have been used. They've been installed on the sides of the motorcycle. Well, hi again. The final design seems to be the most complete and the most welcome design. It's beautiful, has excellent performance, and is inexpensive. It has the same feeling of an old motorcycle with chain. It has more capabilities by removing the gearbox, engine, and the rest of the mechanical parts. The name of this plan is mid-drive. In other words, the motor doesn't apply power to the wheel and uses the motorcycle chain to transfer power. As you can see, the motor is installed here. This electrical motor has 10 poles in the rotor and is a runner model. I ordered the motor for the electrical machinery design team. It had the ability to get power from 3 to 5 kilowatts. It also works from the range of 36 to 72 volts only by changing the size of the coil. The efficiency of the design motor is above 95%. This motor has high efficiency in this power range and has been tested many times by the client. The motor is connected to the chain at the back of the motorcycle. It's possible to change the function is more speed or more power mode by changing the size of the sprocket. There are batteries in this part. These are lithium batteries and custom designed for empty space. This part that you see is the motor driver. The motor driver has been installed under the fuel tank that has been cut. I decided to use the motorcycle tank door to connect the charger connector in the future. The wiring is out of sight, and the fuses are embedded into the fuse box. I've connected the motorcycle key to the motor driver so that the user can turn off and turn on the motor driver as well as the motorcycle. The odometer is intact and usable. I've placed a voltmeter on the front panel to measure the battery charge. I've replaced the throttle handle with an electric throttle handle. Of course, you can keep it in the future and use its own throttle handle. Well, if you agree, let's turn on the engine and test it. Key, throttle handle, motor driver, battery, motor. Key, throttle handle, driver, batteries, motor, chain, and wheel. Stop, and stop. Thanks for your attention. In the past, to make rotors and stators, we glued the sheets together at first, then wired them. But the team found a new innovation. They cut the sheets with a cold nitrogen laser at first. Then we glued them under pressure in a mold that was made from plexiglass. The glue used was Loctite glue, which doesn't stick to the plexiglass. I had that screws or welds would replace glue in the newer versions. The customized curved neodymium magnets were costly and time-consuming, so the rotor has been made of laminated sheets of silicon steel, and the flat magnets have been placed inside it, so that the motor had the function of the curved magnet for in-runner motors. After success in this type of motor, we designed a 1.5 kilowatts motor from the same model for the client. This device didn't have enough space for the heatsink. It was supposed to be in a closed environment. It couldn't exchange heat very well, so we decided to design it with a water-cooled method. Water cools the motor driver first and then the motor. Water pump circulates the water. The motor driver was designed with a bootstrap method without a data logger. The next engine has been designed very small, and I briefly explain it. It's a kitchen hood motor. A kitchen hood production factory had requested this motor. They wanted to reduce sound, noise, and power consumption in their new generation. My first activity in the Demavan Science and Technology Park was the 50 kilowatts BLDC motor design. I was working on this project as a designer and member of the drive and control design team. The main control part and the data logger were receiving data during the test. It was one of my activities in this project. After running the data logger, I made a general data logger. I connected it to LabVIEW and used it in all later projects. I designed an ammeter, which of course was the main problem of this data logger. It has the ability to measure up to 400 amps with an accuracy of 0.1 amps. Calibrating it at different temperatures was another problem. I use Hall effect sensors of the motor in isolated mode for the tachometer. Data logger was measuring temperature with a thermocouple which I installed in the motor. I used the RS-485 protocol and CAN in the later models to transfer information. The video you'll see is the initial test of this motor. I add that the propeller which you'll see was placed on the motor as a load. I'm afraid because of the poor laboratory facilities in Iran, we can't use a standard test system. We had to launch test conditions. It included a fixed load and all data logger equipment. For example, accurate ammeter, tachometer, and thermometer. I connected them to the computer to collect and analyze data. The next project that I'll explain is repair and redesign of Technodyne thrusters. This thruster, which you see in the video and the pictures, had been damaged and hadn't worked. Because of the use of non-standard connectors, water had penetrated into it. The client had requested its repair from the Science and Technology Park. I often don't accept repairs. The park's management had entrusted me with the designs, but at the client's insistence, I agreed and started up the thruster. Then, the client requested to design and manufacture 10 samples of this thruster model. They had to bear resemblance to the main thruster performance. They managed to design it, but the client withdrew from making this project because it had a high cost estimate due to special characteristics, including a magnetic gearbox and working at a depth of 1,000 meters underwater. My next project was the build of a solar power farm, which I add that it was at the end of my career in the park, so it was never finished. We designed it according to the solar thermal power plan. We should have used concave mirrors installed on lots of rails, which is named parabolic trough. The centralized collector, which is named solar power tower, had been also considered. The main idea of the client was to create a solar heat generating panel. He wanted to replace photovoltaic panels for household consumption. Our first step was to make the automatic change of the direction of a photovoltaic panel as a sun tracker. We had to record its data. This tracker was supposed to be used to track the sun in a thermal panel. I add that I left the park after taking the first step and in the middle of the project. The next project that I want to talk about is the gas meter. Gas meters in Iran are mechanical and volumetric. As you know, it's possible to make a gas meter by using an ultrasonic sensor. But we made it like a turbine that had both the ability to measure and generate electricity. It could charge a battery to send SMS or USSD. We made it with the help of permanent magnets and Hall effect sensors. We did it for the reason why the electricity didn't enter into the gas meter for license problems, as well as when the gas meter was used for agricultural lands where there was no electricity. Well, my university thesis was to make a syringe pump. Syringe pump is used to pump medicinal substances that need to be injected to a patient in a small volume and for a long period of time, for example 24 hours. This pump is widely used in operating rooms and ICUs. I used a stepper motor and a driver for it. I divided the number of each step into 16 using the LMD18245 IC. Of course, I could use the idea of this IC to divide each step into 1024 steps with the microcontroller. Using this method and with a good approximation, it's possible to continuously inject drugs to the patient at a rate of 1 cc per hour. I've been working as an automation consultant in the Ministry of Agriculture before I was employed in Damavand Science and Technology Park, as I mentioned in SOP and CV. I've been designing an all-automatic farm by using solar power. Now I want to explain an innovative project that I've done because of personal interest in this period. I'm afraid it wasn't welcomed by the ministry. I personally developed it though. I really enjoyed this research. The project was the creation of an aeroponics bucket. I always welcome research in any field. Unfortunately, agricultural experts couldn't help me in this field. They didn't have enough knowledge and experience, so the project faced problems. I grew the tomato plant in this bucket in the air. Of course, many plants and summer crops can be grown in this way. In this method, The root is kept in the air. Water-soluble fertilizer is regularly sprinkled on the root under high pressure. Irrigation is scheduled 1 second of water spraying and 4 seconds of rest every 5 seconds. NASA invented it to grow plants on other planets for the first time. It has some benefits. For example, impressive and rapid growth, less water consumption, absence of root diseases, also absence of worms and vermin, significantly increased fertility, and much enhancement quality. The left-hand plant in the photo has been planted in the soil, and the right-hand plant has been planted in the air. If the sprinkler system delays a bit, it severely and irreparably damages the crop. So if you intend to use this system on an industrial scale, you need a feedback and parallel operation system. The plant in the aeroponic method bloomed much faster and more than swinging the seeds in the fertile soil. Because I didn't have anyone to keep a watch out for it permanently and didn't have enough experience and knowledge. Sadly, it didn't bear fruit. I stopped trying to improve it due to being busy and not being supported by organization. I also didn't have enough personal capital, unfortunately. But I would like to execute it in the future.